how does life emerge from non-life in our universe? As a matter of fact, we've been conducting, scientific community has been conducting origin of life studies for many, many decades. And we're not getting any closer to an answer on that question. As a matter of fact, the more we drill down into the nature of biological life, the more difficult the question becomes. Now, when we do a good investigation of any crime scene, we ask the questions you probably asked when you were writing a good term paper in high school. What, how, when, where, why, who? These are questions we ask to determine what happened at the scene and who is our suspect. Well, the same kinds of questions could be used to examine the universe and the origin of life. And one of the biggest questions to ask is, what are we really talking about here? Now, you will see in your participants guide the difficult nature of biological life. It's pretty complicated. It's pretty complex. It's not a simple problem to solve. And one of the biggest challenges in all of biology is explaining that largest molecule known to humans called DNA. So that's the what question. What we're trying to explain here is incredibly complex. Another question we might ask is where? Where do we think that life could emerge? Well, I will tell you this. When we look at all the locations that have been offered by people who are trying to determine how life originated in the universe, people have suggested it occurs in the early atmosphere of the Earth. Those actual studies have demonstrated that's a pretty tough sell, and so people have moved away from that. They said, well, maybe it occurred in the oceans or the early oceans, but people disagree about that. And maybe it occurred underneath ocean rocks or at the surface of the terrestrial crust. It's been so frustrating because each one of these locations offered doesn't work for a number of reasons. And as a matter of fact, each of these scientists will disagree with each other and say, well, my theory is better. No, my theory is better. There's no consensus on this at all. As a matter of fact, some now have said that we cannot understand how life could emerge on Earth, so perhaps it was delivered to us on an asteroid or a meteorite from outer space, which just kind of pushes the problem off to another location, but it still begs for explanation. So on the what and the where, we still have some open questions. But when we talk about why did it emerge? What could cause this? Is it a matter of random chance? Is there some aspect of physical law, of physics that made life emerge here? Well, to be honest, we looked at both of those. The odds are so strikingly long against the formation of life from nothing that's really not a good explanation. Sometimes too, when people say chance, what they really mean is I have no explanation at all. So we have to kind of think about that. And in addition to that, we cannot find physical laws of, the laws of physics that could bring together the necessary ingredients for life to emerge. We'll talk about that in a minute. But then we have to ask the question, well, when did it occur? One thing we do know for sure in the entire history of the Earth, life seems to emerge in very striking fashion all at once. The range in which life emerges on planet Earth, even according to the most atheistic scientists, is strikingly short. How do we explain the sudden emergence of species, the sudden emergence of life altogether? So this is something that all of us are searching through to find a good answer. Well, I want to focus in on one thing that I thought, for me at least, was very compelling. And that is this molecule we talked about called DNA. It is the longest molecule known to humans. And it consists of 4 nucleotides that are arranged in a specific order in the molecule called DNA. This order is not just random, it's communicative. It is information. As a matter of fact, the formation of life, all of the micro-machines in your cells, the formation of proteins from amino acids, all of this stuff that occurs in biology is dictated and driven by the genome, by the information, the nucleotide sequence in your DNA. Think about that for a second. If that's really information in DNA, how do we get it? Where does information come from? Stephen C. Meyer is a philosopher of science, and he made a very striking observation, which I think is pretty sound, and that is that we don't have a single example anywhere in the history of science, anywhere in the history of the universe, in which information has ever come from anything other than intelligence. Do you think physical laws can produce information? Some people would say yes. Well, that depends on what kind of information you're actually looking at. So I wanted to describe for you the 4 levels of information, or the 5 levels of information, to show you how complex DNA information is and why it screams for an intelligent mind as the source. Imagine you probably have a dog. I have a dog. I have a great dog, by the way. It's a Welsh Pembroke Corgi named Bailey. I mean, Corgis are great dogs. That's why the Queen has, 10 of these dogs? I mean, it's awesome. But I will tell you that she may not be the smartest dog in the world. If I gave her a typewriter and asked her to bang out a sentence, her first effort looks like what you're seeing here. Is that information? I mean, it's a sequence of letters that are all jumbled around. I mean, is that information? Well, in a sense, it is information, a very low level of information. It's a sequence of letters that's complex. I doubt she could type that same sentence twice. It's pretty complex, but it's not specific. There's no specificity. I see no words. This is a level of information that is called statistics by an engineer named Werner Gitt, who has done some work on the levels of information. It's the lowest level of information, just like small repeating patterns, even more complex repeating patterns. This is all information, but it's the lowest level of information. Yes, you could get this kind of information from inside the room of the natural universe with just space-time, matter, physics, and chemistry. Granted, but this is not what DNA is. Let's go another level. What if Bailey, my dog, could get on that typewriter and she could actually type out words like you're seeing now, but they're not words in any particular sentence order. I still don't know what she's trying to tell me, but hey, at least she knows this. She can code for certain words that I can then understand, recognize, and decode. This is a whole nother level of meaning, a whole nother level of information. It's described as cosyntax. Now, this is level 2 information. And there's actually no way to get this level of information from inside the room of the natural universe. You need a mind that can code and understands the formation of words, even understands how these will be read by the receiver. We are now one level outside of what the natural universe can do for you. And we are still not at DNA. This is another level of information, but we're not close to DNA yet. What if Bailey could type out words and actually put them in a sentence? Grandpa is eating. You see, the sentence now has meaning. I understand what Bailey's trying to tell me. She is trying to tell me that Grandpa is eating. This is another level of information. This is called semantics. But we are still not at what DNA is. And we're now 2 levels outside the room of the natural universe in terms of what space, time, matter, physics, and chemistry can deliver. Well, what if Bailey could actually not just type out a sentence, but she can make a request with her sentence? Think about that. Oh my gosh. Well, how would she do that? Here's a sentence, for example. It's clear she wants Grandpa to feed her. Okay, this level of information in which the sender is actually making a request, well, this is a whole nother level of information. We're now 3 levels outside of what the room can do, and this level is called pragmatics. It's very useful, very practical. But what if Bailey's even sharper than this? She's asking Grandpa to feed her not because she wants to get fed. She's asking Grandpa to feed her because she knows that after every meal, Grandpa takes her for a walk. If the goal Bailey has is to get something that happens after the request that she knows is coming, this is called apobetics. It's the highest level of information, and it turns out 4 levels now outside what the natural universe can deliver. We are finally at the level that we see in DNA. How in the world are we going to explain this? Remember, low-level information like Bailey's first sentence you see here is no way to tell what it means. And I can even take a character out, and it makes no difference in terms of meaning. But go to the highest level of information. Do you see her sentence here? Let's eat, Grandpa. Well, if we take out the comma, the same comma we took out in the first sentence, do you see how the entire meaning of the sentence changes? This is no longer Bailey asking to be fed. This is Bailey who wants to eat Grandpa. Do you see the difference? This is how we know it's the highest level of information. Well, think about this. You and I, we have a DNA code that describes everything about us. And there are now genetic therapies in which all they try to do is change the information in the DNA because subtle changes to the nucleotide sequence produces physical changes in meaning, in structure, in how we are as humans. This tells us that DNA is at the highest level of information. Far more than statistics, we are looking at the level that has now been called apobetics. And the reason why that's so powerful is because we've got to try to explain how we've got that kind of information in our universe. Can we stay inside the universe to explain that? Now, there are a couple of ways that people have tried to explain it. They all fail. They can't explain really how we get this level of complexity and specificity in DNA. They can't explain where this might emerge. They can't explain when this might emerge. Now, there is another explanation for DNA. If it's not going to be chance, which it isn't, and it's not going to be physical law, which they have to demonstrate to us that physics can somehow produce information, and they haven't. There's another option, and that is that it truly is information. Information that comes from a mind. Now here's what I'm seeing. In all those questions we started with, the what, when, why, where, who questions, the one question that science refuses to ask is the who. They're willing to ask the what, when, why, how, where, no problem. But what if all the evidence we have points to a who and not a what? Are they willing to ask the who question? Well, no, they're not. Well, why not? We don't do science that way, Jim. Really? Well, why don't you ask who questions? Because there are no who's in the natural universe us to ask. It's a what. It's going to be a what. Well, wait a minute. What if all the best evidence you had points to a who? Are you willing to entertain the possibility of a who? And here we have something in the universe, information, which is best explained by a who, an intelligent mind that is the source of the information in the DNA. Once again, we have to jump outside the room of the natural universe to explain what we see in the room of the natural universe. An all-powerful, timeless, spaceless, non-material, uncaused first cause that is a fine-tuner, creating a universe that has purpose and meaning and is designed to support life. But not only that, he is communicating to us through the DNA in order to originate life in this universe. He's set the table and now he's delivered the goods. And we are outside the room for our explanation.